Hi guys, Buildzoid here, and today we're going to be taking a look at another DDR5 memory overclock. This is on a memory configuration that I almost called cursed, but then I thought about it a little bit too hard and for too long, because, like, what this is I've taken these two Corsair SK Hynix-based engineering sample memory kits. These are 6200 megabits per second XMP, which XMP is an overclock, by the way, so technically we're still overclocking even though we're nowhere near 6200 megabits per second. We're just overclocking less than what the XMP does, which is what happens when you have a very slightly cursed memory configuration. The thing about this not being all that cursed is that, like, this is a bad idea, right? Z690 motherboards use daisy chain memory topologies. The DDR5 memory controller in 12th gen CPUs is not particularly amazing, as you would expect from a first generation memory controller, and so consequently when you stick 4 memory sticks onto it, it gets rather upset with you. But the thing is, this could be so much worse, because these memory sticks still use, regular X8 memory chips, so the memory chips themselves are actually perfectly good. They're SK Hynix memory chips, so they're actually, like, as far as available DDR5 memory chips go, this is as good as it gets. And we're only dual rank, right? Like, the truly cursed configuration would be like triple rank or quad rank. Triple rank would maybe be more cursed because it's like weird and asymmetrical, and that does actually cause some really funky issues, at least with DDR4, where, like, the memory stick order really matters because one of those sticks has, like, probably has completely different signaling properties compared to the other stick, so which stick goes where suddenly matters a whole. Like, with DDR5 already, that kind of matters a bit, but when you've got a triple rank configuration in your system, which stick goes where is very important. So this isn't as cursed as triple rank, or as cursed as quad rank, because quad rank just loads the memory controller like crazy. But as far as DDR5 memory configurations go, I would really not recommend that you buy 4 separate DDR5 memory sticks and then stick them into your system, because things are going to be very difficult. In fact, they're going to be so difficult that some CPUs, like the settings that I've, let's just take a look at the stress testing that I've done, right? So this right here has run 1000% of memtest, and it has passed over half an hour of linpack. So I would consider this very stable. But funnily enough, the settings that the system is currently running do not work at all with my 12900K. I spent many hours trying to get my 12900K to run the settings that are currently running on the system that passed 1000% of memtest, and I couldn't get that 12900K to do it. I couldn't get past 10%. I tried lower memory speeds, it still wouldn't get past 10% of memtest without spitting out errors. Because the 12900K, my 12900K's memory controller is just completely incapable of running this. So we're on the 12600KF, which I'm not thrilled about, because the 12600KF has less cores, and therefore stress testing 64 gigs of memory takes even longer than usual, but at least the memory controller isn't a pile of trash. Though there is potentially the possibility that the slightly lower core count puts less stress on the memory controller, and that might be why the 12600KF is stable while the 12900K wasn't stable. However, the 12600KF also just has fewer issues with memory training. It generally just clocks memory higher in single rank configurations. This is a dual rank configuration. So the memory controller on this 12600KF is definitely better than on the 12900K, but when you have different core counts, the stability effects might be partially also tied to the core count, not just the memory controller. But yeah, anyway, so that's kind of like I think this is dumb. I think if you need a lot of RAM, you should be buying DDR4, because with DDR4, at least as long as you have a K SKU, you bump the VCCSA and you should be able to run 3600 megabits per second in Gear 1 without any issues. Even if you get 128 gigs of DDR4, you should be able to do 3600 megabits per second, no problem. Whereas with DDR5, well, let's just take a look at what Intel thinks their DDR5 memory controller is capable of. So here's the official Intel 12th gen documentation. And here we're on the page where they talk about their supported memory configurations. So, officially with the DDR4 memory controller supports up to 3200 megabits per second, and the DDR5 memory controller for 1 DIMM per channel motherboards. Okay, so this is boards like the Apex, the Tachyon, the Dark, the Unify X. For those motherboards, it officially supports up to 4800 megabits per second on SODIMMs and UDIMMs. In practice, those boards can generally hit like 6800 megabits per second and higher. But Intel's official specification is always within like very conservative. But for 2 DIMM per channel motherboards, which is all of your normie motherboards, 1 DIMM configurations are expected to only hit 4400 megabits per second, which luckily is not true. But technically, even 4800 megabits per second on any motherboard with more than 2 memory slots is actually kind of a violation of Intel specifications. So that's kind of fun. But if you go to the memory configuration that we're running right here, right now, which is 2 DIMMs, 1 rank on each, 2 DIMMs on each channel, 1 rank on each DIMM, so a dual rank memory configuration. Yeah, Intel only expects that to hit 4000 megabits per second. I guess the 4400 is also supported for dual rank DIMMs, because they don't mention how many ranks they support this with, so... yeah, I guess if you had 32 gig DDR5 DIMMs, which currently are dual rank, then it's supposed to work at 4400 megabits per second. Anyway, this is why if you buy like 4 sticks of DDR4 and you stick them in, DDR5 and stick them into your motherboard, some motherboards will default to like 4000 megabits per second. Gigabyte motherboards default to 4533 megabits per second, which again is an Intel spec violation, but nobody really cares about the Intel memory specs anyway, so, it's not really that surprising. But when you get to like 2 DIMMs and dual rank, so this is if you wanted like 128 gigs of DDR5, which is just a horrible idea. Yeah, Intel only expects that to work at 3600 megabits per second. Like, you could literally just buy DDR4 instead at that point, and it would probably be more stable. Anyway, so for the purposes of this video, yeah, if we look at the, spec of the memory kit that I'm using, memory kits that I'm using, these are 6200 megabits per second memory kits. The settings that I'm running are actually very disappointing because, well, we've got too many memory sticks. But if you compare the settings that I'm running to what Intel officially supports, I am running quite the overclock. In fact, I'm just going to pull up the calculator so that we can calculate this. We are 35% above spec. And that's not including also the fact that a lot of the timings are a lot tighter than expected. So anyway, let's get to the actual settings and talk a bit about the performance. I'm actually surprised at the performance of this. I was expecting it to be way worse. But then again, there's also I have a CPU that literally can't run these settings at all. So I guess, if I used my 12900K for this, then yeah, the performance would actually be even worse than it currently is. Anyway, and there is a bit of an issue that I actually don't know how, I've not tested single rank LinPack with my 12600KF. Also, there's a chance that the 12600KF just simply doesn't have enough number crunching power to really, memory bottleneck in LinPack. Because it's only a 6-core. Right, and for something like with LinPack, your memory, how much your memory bottleneck depends on how many cores you have. So with a 6-core CPU, it's going to be less bottlenecked with an 8-core CPU. So arguably, the fact that the memory settings are kind of miserable is less of a problem on a 6-core CPU than on an 8-core. So performance-wise, basically, it's hard to do a real-world, or it's inconvenient to do a real-world ish test. The synthetics are pretty happy with it. I mean, if you look at IDA's memory bandwidth, the read test is miserable, the write test is miserable. As far as I'm concerned with DDR5, you should be aiming for close to 100 gigabytes per second or more. This is in the 80 gigabytes per second range. So yeah, I'd say miserable, miserable, miserable. Though, if you are doing like video encoding or compression and decompression, like memory intensive workloads, this will actually be faster than DDR4 because DDR4 isn't doing 80 gigabytes per second, at least not on a. Well, you're not doing. Actually, you might be able to. With Micron memory chips, you might be able to get around 80 gigabytes per second, but DDR5 also has a bunch of efficiency advantages, so, like, peak performance in IDA doesn't really reflect, you know, real-world workload performance, which is why I don't like using IDA very much, but, yeah, anyway, I gotta say, like, I'm kind of surprised by the latency result. 59.3 nanoseconds is not the worst latency I've ever seen on DDR5. So yeah, I'm pretty surprised by that because I was expecting way worse, and then I ran the latency test and it was like, oh, actually, like it's bad, right? Like with DDR4 and good DDR5 setups, you could be like good DDR5 setups, you're going to be approaching the low end of 50 nanoseconds. With like strong memory controllers and strong boards, you can actually push DDR5 below the 50 nanosecond range. And with DDR4, you should be in the 40 to 45 nanosecond range, generally speaking. But yeah, with a dual rank DDR5 setup, where it's 4 memory sticks on a daisy chain motherboard, 59.3 nanoseconds. I'm surprised. I really wasn't expecting this to get under 60, but it did. So that's kind of neat. Geekbench is. Like 12K is not terrible, but like I am used to, like for a daily setup for DDR5, I'd be aiming at like 13,000 points to 14,000 points. But 12K is not the end of the world, and it is more memory performance than you would get out of DDR4. So again, like in workstation workloads, this is actually viable, assuming that you have a CPU capable of running the memory at these settings. So. Yeah. Anyway, and then we have the Intel memory latency checker, and this actually hit 52.6 nanoseconds, which, yeah, I really didn't expect it to get that low in latency in memory latency checker. But yeah, the loaded latency is pretty miserable. You can get lower, you can get significantly lower than 86 nanoseconds, but that's like max load, and then in like medium loads, it's doing okay-ish, I guess. Yeah, so like stability wise, it is stable, 1000% mem test. I don't usually run out to this, like this percentage just because it takes forever, especially with 64 gigs of RAM. It takes for absolutely forever. But I left it overnight. Like I went to sleep. So when I woke up, it was at 1000%. And, yeah, that's great. And then LinPack passed 30 minutes, so that's fine. I didn't bother to run Y-Cruncher because the main I don't know how it like performance. Like I don't have a performance reference, so I don't really see much point in running Y-Cruncher when I don't know what a good score for Y-Cruncher would be right now. But yeah, like honestly, like this is like it's bad. It's not as bad as it could have been. The main problem with like multi-rank DDR5 setups, in my opinion, is that you don't get like the performance benefits of multiple memory ranks like you did on DDR4. So the thing with DDR4 is that when you go from single rank to dual rank, you basically get a performance per clock uplift that's roughly equivalent to increasing the memory speed by 400 megabits per second. So basically what that means is a single rank memory setup of DDR4 at like 4400 megabits per second has basically the same performance as a dual rank DDR4 setup at 4000 megabits per second, which means the fact and dual rank memory configurations clock worse than single rank memory configurations, but the point of this is that when you go from single rank to dual rank on DDR4, usually you don't lose performance. In fact, a lot of the time you'll gain performance because the speed penalty doesn't outweigh the efficiency improvements of having 2 memory ranks. But the reason this works with DDR4 is that on DDR4 a single rank of memory only has 4 bank groups. So you go from having 4 bank groups to having 8 bank groups, and with more bank groups available, the memory controller can use short delay timings more often than long delay timings. Basically, if you want to access do a memory access to the same bank group twice, that takes longer than if you are accessing data in a different bank group. So the more bank groups you have, the statistically, you're more likely to be using the short timings rather than the long timings, and so dual rank gives you a nice big performance boost. With DDR5, you already have 8 bank groups in a single rank of DDR5, at least if you're using X8 memory chips, which you should be, because X16 memory chips are bad. So, like, yeah. And basically the only way to get X16 memory chips with DDR5 right now is if you buy 8 gig DDR5 DIMMs, so just avoid those. Just get 16 gig DIMMs of DDR5 and you'll never have to, well, for now you won't have to worry about that. I imagine sometime in the future we'll have like 32 gigabit ICs and then X16 memory chips will be viable for 16 gig DIMMs, but as of right now, if you buy a 16 gig DDR5 memory stick, it's going to be using X8 memory chips and you don't have to worry about the X16 stuff existing. But anyway, so if you have a typical 16 gig DDR5 stick, it has 8 bank groups. It just has them. And so when you go from single rank to dual rank on DDR5, you're going from 8 bank groups to 16, and you might be like, oh, but, you know, like you've literally doubled the number of bank groups again. Why don't you get a huge performance uplift for that? Well, the thing with DDR4 is you see that same effect when you go from dual rank DDR4 to quad rank DDR4. Quad rank DDR4, from a performance perspective, has minimal gains because there's a limit to how much rank interleaving your memory controller can do. And so going past 8 bank groups just generally doesn't do much for performance. On DDR4, it doesn't do much of anything. On DDR5, it also doesn't do much of anything. So with DDR5, sort of the peak performance configuration is single rank, and with DDR4, peak performance configuration is dual rank, because you want 8 bank groups. And more bank groups than 8 doesn't really do anything because you've already got enough bank groups to begin with. So, yeah. Anyway, so that's kind of the main problem with, or I don't know that I would consider it a problem, but that's like the main reason that you're not gonna get like a big performance uplift like you do with DDR4 when you go from single rank to dual rank. Is just like single rank DDR4 is actually like really inefficient. So going from single rank to dual rank massively boosts the efficiency and, you know, you get a nice performance uplift. But going from single rank to dual rank DDR5 doesn't really do anything because the single rank DDR5 is already very efficient because it has 8 bank groups to begin with. And it was designed with 8 bank groups specifically for the efficiency improvements. Like that's why why DDR5 is built the way it is just like more bank groups, more better. And so DDR5 just comes with them from the get-go. Anyway, let's take a look at the actual settings that I'm running. So yeah, and we're going to do that in the BIOS. I'm just going to take a screenshot of this. So for reference, take a screenshot of all of this and let's go into the BIOS. Now I do have fast boot enabled on this, and I've not verified yet whether or not like I can turn off the power supply and it'll still fire up properly. It should, just like based on my experience messing with DDR5 so far, this shouldn't be a problem. And we're at such a low memory speed that I don't think the memory controller is going to have retrain issues. But yeah, we'll see. Like I will check that and I'll leave a comment under the video or in the description, like somewhere. Anyway, yeah, so here's the settings. CPU's at 5.1 gigahertz, rings at 4.8. The memory's at 5400 megabits per second. So that's, yeah, we're like relative to what Intel officially supports for this memory configuration, that is quite the overclock. Relative to what this memory kit is rated for, that is quite the underclock. Anyway, for voltages, I'm 1.35 volts on the core, 1.1 volts on the VCCSA. The thing is, if you're not running a high memory speed, you really don't need a lot of VCCSA, and too much VCCSA can cause weird issues with 12th gen CPUs. So it's better to keep it lower rather than, or well, It's better to, like, I wouldn't stress about, like when I set VCCSA, I basically set it in like 50 millivolt increments. I wouldn't worry about dialing it into the nearest 5 millivolts or something. Or actually, I don't even test it in 50 millivolt increments. I basically test like 1 volt, actually, like 0.95, 1 volt, 1.1, 1.2, 1.25, 1. Actually, okay, so basically 50 millivolt increments. Anyway, so 1.1 volts is more than enough for this setup. It's stable. Yeah, I'm not going to mess with that. Because the memory controller speed is really low, right? We're in Gear 2 with DDR5 and 5400 megabits per second, means that the memory controller is running at 1350 megahertz? Yeah, which is basically nothing. That's like the equivalent of DDR4 2666. VCC in is up at 2 volts. This doesn't hurt anything, and it can help with memory stability a bit because there's like the VDDQ and the VCCSA are derived off of VCC in. So yeah, I just like to set that to 2 volts and call it a day because it's fine. Like, it's not going to cause any issues, and yeah, that's kind of that. So that's just at 2 volts. VDDQ, so this is a wacky thing about Gigabyte boards. The DRAM VDD/VDDQ setting also sets the CPU VDDQ voltage, which is not accessible in any other way, shape, or form. Right? Like, you have this VDD/VDDQ setting. This sets the CPU VDDQ voltage. So that's at 1.35 volts. Then the VDD2 voltage, which Asus likes to call memory controller voltage because Asus have like a naming department that comes up with unique names for BIOS settings. Anyway, VDD2 is at 1.45 volts. This is basically the voltage the memory controller uses to communicate back to the memory sticks. Most of the time, you want your VDD2 voltage to be the same as your memory's VDDQ voltage. So that's the case in this configuration. I have both at 1.45 volts, and I also have VDD at 1.45 volts for the memory. Honestly, this might be a bit more, like, this might be more voltage than the memory really needs, but well, I do have a fan on the memory sticks, so I don't really have to worry about that. Yeah, like, it's stable. Like, the funny thing is, I really didn't expect this to work, because I was struggling so much with my 12900K that, you know, I got the idea, oh, I'll just stick the 12600KF in there, and if it fails in like 50% to mem test, I'll give up on this. But, you know, I started mem testing it, and it just kept running. And it didn't stop running until, like, you know, so, yeah. I've never went back to fix the voltages. Because with the 12900K, like, I tried so many different combinations of, like, memory voltage, VDD2 voltage, VDDQ. I tried messing with the mounting pressure, because with DDR5, if you don't have enough mounting pressure or too much mounting pressure, you lose, like, it won't train. So with the 12900K, I just spent hours trying to get, like, 50% of mem test to pass. And then I switched to the 12600KF with settings that were completely half-assed, and it's like, oh, it runs. So that's why the voltages are the way they are, because there's a very, like, especially the memory voltages are really unoptimized. There's probably headroom for me to actually lower the primary timings with them set as they are right now. But I am happy that it passes, and I am not going to touch the settings any further. Also, I don't think there's that much headroom. Like, I think CL26 would probably work instead of CL28. But going from 28 to 26 is just not really going to do much of anything for the overall memory performance. TRCD might do 33 or even 32. TRP might do 33 or even 32. Also is not going to do anything for, like, that shouldn't really affect the overall performance much, but it would help more than changing the cache latency, though. Like, going from 34 to 32 on TRCD is more useful than going from 28 to 26 on TCL, just because TRCD is a more important setting for overall memory performance. Anyway, TRAS can't go any lower. 28 is as low as the register on the CPU goes. Then TRC on Intel CPUs is not real. This is a timing that gets calculated based on your other timings. You can't actually, like, set this. TWR is also not real on Intel CPUs. There's other timings that you set to adjust that. TCWL is at 28. Arguably, this could be also at 26, but it's a similar situation to the cache latency itself. Is just like 2 ticks of TCWL is not going to make this this is not gonna drastically change the performance at this point. This is like going from say 5200 or 5400 CL40 to CL28. Yeah, that's actually quite a difference because you're dropping the timing by like a third almost. Lowering the timing by like 10% is not going to make much of a difference, which is why at this point, like, it could probably go lower, but I'm not bothered about it anymore. TRRDS is at 4. It can't go any lower than that. Literally, like, the register on the CPU doesn't go lower. TRRDL is at 7. That might go lower, but I'm just happy that this runs. So I'm not messing with that. Then we get a bunch of other memory timings that aren't actually present on Intel memory controllers, so that's always fun. TRFC is not used with DDR5. Instead, you use TRFC2. So TRFC2 is set at 333. It could probably it can maybe go a couple ticks lower than this, but going from like 333 to 299 is probably not going to do anything. So, like performance-wise, that's not really going to make too much of a difference. So I'm not bothered about it. TRFC per bank is at 255. It might do 233. It might even do 220, 222 or 21 or 21.1. So this could go a bit lower, but the thing with the refresh timings is if you set these too low on DDR5, you don't necessarily get instability. You might lose performance first because these are the two, like the refresh cycle, like overall refresh cycle per bank, and refresh interval. These are like the 3 timings that'll actually get affected by the built-in on-die ECC, because the built-in ECC for DDR5 is primarily to prevent data disappearing from the memory chips themselves. And so if your refresh timings are too short or too infrequent, if your refresh interval is really really high, which 65,000 is maxed out, and I'm willing to max it out because, well, it's maxed out for gigabyte motherboards because technically the register on the CPU goes all the way up to like 260 something thousand. For whatever reason, Gigabyte's BIOS doesn't let you set it to that, which is a bit annoying. But the thing is, even at 260,000, like, which I've used for benchmarking, I've not really noticed any drastic stability problems. So at 65,000, I'm really not concerned about it. This shouldn't cause any issues. But at 260,000 with really low refresh cycle and refresh cycle per bank, I have occasionally seen some strangeness with memory performance. So yeah, and that's basically due to the on-die error correction, which if you basically don't refresh the memory often enough, your data starts to disappear. And the on-die error correction is actually meant to counteract that. So, like, you could push these lower. It probably wouldn't change the performance much. And if you push them too low, you're going to start losing performance before you necessarily encounter instability. Arguably, also, if your memory sticks get too hot, the on-die error correction is probably going to get slammed. Anyway, below that we have TFAW, which is at 16. It doesn't go any lower than that. Command rate is at 2. If you set it to 1, this won't train anymore because we've got, a dual rank memory setup, and the more, command rate basically controls how long the memory controller holds commands on the command address bus. So the more load you have on the command address bus, which basically depends how many memory chips are connected to it, the harder it is for commands to be correctly read, and so you need to hold them for longer than if you have less memory chips. So 2T command rate is actually with Gear 2, this is technically holding that command for 4 memory clock cycles, but we'll just ignore that. But anyway, so this is just a necessity for stability in this current configuration. If I set that to 1T, it doesn't train anymore. Single rank DDR5 setups on many motherboards can actually do 1T command rate, but with dual rank, I don't think that's going to work just because there's so much more stress on the command address bus. Arguably, it might also be a matter of like dialing in the memory controller settings for like the difference in timing delays between the two memory sticks, but yeah, I actually, like, you'd have to ask somebody who works at a motherboard vendor about what the issue is with getting lower command rates to work exactly. But for now, the way you get this to work is you use 2T because 1T doesn't work. And there's, and I don't know the exact reason for it, but that like you wouldn't really expect 1T to just work on dual rank setups. Anyway, TXP's at 4. You can pretty much always set TXP to 4. Doesn't really affect stability. Reduces your memory latency. So this is like a no-brainer. And it doesn't go lower than 4. Then we get to the settings that actually set your TWR, which are TWR PDEN and TWR pre. I have them both at 57. They can probably go lower. I wouldn't be too surprised if they could do like 32 or 36 or something. But I am just happy that this ran. This is like, I am not running another stress test, and I am not changing those. This is already a big improvement over what they are at stock. Like, at stock, they literally default to like 100 plus. So it is faster. It's just, yeah, those aren't minimized. TRD pre's at 8. The lowest TRD pre I've been able to run is like 6. So this is about as low as that's likely to go. And I forgot to set the TCKE to 4, but luckily that timing doesn't really do too much for performance, so I wouldn't worry about it. Anyway, then we get to the tear cherries. And this is the really disappointing part for me with the dual rank setup, because you have like, so you have read to read different rank, read to read different dim. Because we don't have multiple memory ranks on each dim, we have different DIMMs. In this configuration, the only timing that should be applied is the DD timing. Though if I was actually setting these manually, I'd be setting both the DR and DD timing at the same time to the same value. However, they don't work if you set them to the same setting as your same group timing, which is quite disappointing, because with DDR4, generally you can set your like different rank and different DIMM timings to the exact same value that your same group timing is. And yeah, you can't do that with DDR5 for some reason. You can't actually even set them to 13. Like that also just seems to just cause issues. Admittedly, I did most of that experimenting with the trash 12900K, but yeah, I'd like, you know, going from 14 to 12 is not really going to drastically change the performance. And so that there's not really too much point in messing with that. And going from 14 to 13 is just, yeah. So this is like, but that is a disappointment, because that is one of the other things that would have helped this configuration sort of gain back some of its performance, like some of the performance lost from the low speed. But yeah, you can't really run the different rank and different dim timings very low, as far as I can tell, because it just stops working. Yeah, and then we get to the read to write timings, which these could be lower. Like these two should probably do 18, maybe 17s on both of those. These two can probably do 20s, maybe even 18, maybe even 17s. The thing with these four is they don't, like, I have occasionally set them too low, and they're not exactly the ones that, well, going from 20 to 18 is not going to drastically improve benchmark scores. And I, like, again, like the 64 gig setup is just, I really, really don't like working with this, so I didn't want to spend too much time on it, and so these are definitely not minimized. But there's also not really, like, compared to stock, there's just not that much headroom in them anyway, so I'm, like, not, like, if this was my personal system, I'd actually just call it a day. I wouldn't bother with those. Then we get to the right to read same group and right to read different group. These are at 60 and 46. 46 is generally, well, okay, I don't know about at 5400 megabits per second. If you're above 6000 megabits per second, it generally doesn't go below 46. At 5400 megabits per second, it might actually go a bit lower, but not much lower. And read to write same group, I mean, right to read same group is at 60, because the lowest it really go, like, generally can't set it below 56 in my experience, and 56 doesn't always work. So I have that at 60. Anyway, and then the round trip latencies, that I'm just letting the board take care of those on its own, because you, like, if you try to manually set these, it won't work. And then the termination settings, those are all on auto. Arguably, fiddling with these would potentially help with the stability. However, there's not like, there is too many of these. Like, and also these aren't timings. These are termination resistances. These affect the signal quality between the memory sticks and the memory controller. And And unfortunately, like, there's really no way to know if your adjustments are making an improvement or making things worse other than to watch if the stability gets better or worse. And that is extremely tedious to do. And yeah, I'm just gonna let the motherboard deal with this on its own because like I have no interest in trying to figure out the optimal termination configuration for a 4x16 DDR5 setup. Um, like, yeah. Anyway, oh yeah, and then I have fast boot enabled, and the main reason I have fast boot enabled is because if you disable it, well, let's see. Let's see how long this takes to train. Also, how many times it attempts to train. That's the other thing, is it generally takes multiple attempts. Like, this is probably going to be a 54, yeah. So if you don't have fast boot turned on, it's going to like do 3 training loops, in my experience. Though once you turn fast boot back, like, so yeah, this is another argument against this, but the thing is, this actually doesn't, well, okay, no, with my 12900K at this speed, this happens always. There's just never a situation where it doesn't behave like this. With my 12600KF, this only happens after you tighten the timings. Though I've not noticed any instability, which is kind of like, yeah, so. Oh, and it already managed to train. That was actually, wait a minute. No, it maybe not. Yeah, so this is the thing, is if you don't have fast boot turned on so that it just, because what fast boot does is it basically tells the memory controller to just keep the settings that it already used to boot once. Whereas if you disable fast boot, you're telling the memory controller that it has to retrain. And on auto, like if you leave this on auto, you'll actually have sort of a mixed behavior where it'll sometimes retrain, sometimes it won't. I think with this setup, I would probably have it with enable fast boot. Like, one of the concerns with having fast boot enabled is if like your ambient temperature drastically changes, you might find that it won't train. But like, I have very limited experience with that. So for this setup, like, the funny thing is, like, I really don't put, like, I don't put my personal system to sleep. I don't really turn my personal system on and off very often. So actually, I would be perfectly happy to just turn fast boot on and just not worry about it. But I guess if you're power cycling your system very often, this might be a concern. That the, like, this could be an issue you could run into. I'm not sure how, like, I don't have a good fix for it right now. I would try to basically daily this with fast boot turned on. And probably do like periodic stability checks sort of at random. Like maybe, you know, in the first month of using the system, I'd run a mem test overnight, like after a restart. But yeah, not really practical. Like, just running this much DDR5 is a bad idea, and you're signing yourself up for a bad time. So, like, you have 2 options. You can have miserable performance, or you can or you can spend like a ton of time validating whether or not your system is actually stable. I guess you could also just YOLO it and pray that it's stable and not worry about it. That's also an option, you know. Just pretend that it's stable until it crashes or something, which is not great advice because you can end up destroying your operating system by running a system with unstable memory settings, and it'll like corrupt your files. And yeah, you're gonna, like, if you're gonna do that, I highly recommend that you have all your data backed up because your OS might go bye-bye very quickly. Or it might take several months. Like, I have operating systems that survive several years of my abuse, and then I have operating systems that die in like a couple hours. So anyway, yeah, I think that's everything I wanted to cover in this video because, well, actually, oh yeah, also the one thing you need to be aware of with fast boot is if you have it enabled, you can't change any memory timings. You have to disable fast boot in order to be able to make any timing adjustments. And anyway, that's everything I wanted to cover in this video about this memory overclock. Is just, yeah, like I mainly tested this out of like a vague interest of like, so how, because I already know, like like relatively close to launch I already messed with a 4x16 setup, and I very quickly realized like like you don't make up the performance, right? Like the speed loss is far greater than the like efficiency gain from going dual rank. And that's kind of why I just ignored it, because it's just like, well, it's bad. And then eventually I got these two Corsair memory kits, which actually use SK Hynix chips, because my original testing was on Micron memory chips. And so with the SK Hynix chips, I was like, well, maybe with better memory chips, it'll be possible to run this at like, I don't know, 6,000 megabits per second or something. And the answer to that question is no, it's not. At least not with this CPU and this motherboard. Maybe there are motherboards out there that can do higher speeds in a 4x16 configuration, but or CPUs that can do higher speeds in a 4x16 configuration, but this is not one of them. And I'd say most setups can't work with this, because like I've seen a lot of complaints online about 4x16 being a nightmare to run, and it's like, well, yeah, like that's exactly what it is. Also, I'm just rerunning the IDA latency test right now, because right after boot, you actually, like it, well, assuming that your OS doesn't have a bunch of stuff that turns on at startup, you're generally going to get the best IDA latency right after, like in a few runs after a fresh boot. Because I have actually seen these settings spit out a 58.3 nanosecond IDA latency at one point in time. Though it looks like we're not going to get that lucky. Well, 59 is not that bad, considering that we're only at 5,400 megabits per second. So, anyway, yeah, is it for the video? Yeah, that's it for the video. I'm not going to rerun it anymore. I want to move on to better memory configurations with less issues. So yeah, that's it. Thank you, Gigabyte, for the motherboard. Thank you to my patron, and Corsair for the memory kit, and also thank you to the patrons for the 12600 KF that doesn't suck, unlike my 12900K, which sucks horribly at memory overclocking, and CPU. It's just generally not great. Anyway, yeah, that's it for the video, so thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store, where you can pick up shirts and hoodies and posters, the usual YouTuber merch. And I also have a Bandcamp, where I post background noise. You might want to check that out. There's a link to that down in the description below as well. And that's it for the video. Thanks for watching, and goodbye.